Seekers of truth. Welcome to the lesson on Rolle's theorem and the mean value theorem for derivatives. Okay, so let's dive right into it and let's look at what this theorem is saying and then interpret what it means and some of the conditions. Okay? So it says, let f be a continuous function on a closed interval AB and differentiable on the open interval AB. If f of a equals f of b, then there is at least one point in AB exclusive where the derivative of c is equal to 0. So all this is very wordy, so let's just draw this out and then we'll discuss it. So I have some function between a and b. It's continuous between a and b inclusive, and it says here that f of a is equal to f of b. So there's that. Okay, and it's continuous everywhere, and it's differentiable everywhere except possibly at the endpoints. Okay, so it's differentiable in this interval. Okay, so that just means that like outside of the interval there could be a cusp or some some weird change, and that's okay. Okay, but in between here, f of a is equal to f of b, so the y values of these are the same. Okay, and what this theorem says is no matter how you draw this, and you can get really crazy as long as you make it differentiable. As long as it's differentiable from A to B exclusive, then there's a point somewhere, there's got to be a point somewhere in here such that the derivative at that point is equal to 0. In other words, there's got to be some point in here where the slope of the tangent line to that point is equal to 0. Okay, so in this case, there's actually a couple, right? But this theorem says that there is, at least one. Okay, so like no matter how you draw this, there's got to be something here. Okay, and I'll just make a note here that this is it's like okay if not differentiable at endpoints of the interval. So this is a theorem that's only talking about what's happening inside the interval. So at the endpoint, it may not be differentiable, but this theorem still works. Okay? So just think about every possible way that you could draw this function according to what the conditions are. And no matter how you draw it, okay, there exists at least a point. So there's actually 3 points here. There's this C. There's another point here that we can call something else, and there's another point here that we can call something else. But there's no matter how you draw it. So let's say we're very restrictive. So let's say this is A, this is B. Let's say and remember the rule is that f of A must equal f of B. Then we can draw it this way, and that's still true, right? At here at C, f prime of C is equal to 0. So there has to be at least one point. Okay, such that the tangent at that point has a slope of 0. Okay, so that's about all it for Rolle's theorem. And there's a nice proof to this. We're not going to get into that right now. We're going to move on to the next theorem, and then we can see how these theorems are applicable to some situations. Look at this mean value theorem, and it says that let f be continuous on a closed interval AB and differentiable on the open interval AB. So same thing, it may not be differentiable at the endpoints. Okay, there is at least one point C in AB such that this expression is true. Okay. And so to understand what this is saying, let's again draw a picture and look at the results. Okay, so here we have some interval AB, and it doesn't say anything about f of A or f of B. It just says that it has to be differentiable. So A could be anything, B could be anything. So just for fun, I'll make B smaller than f of B smaller than f of A. And let's say this function looks something like this. Okay, it doesn't really matter how we sketch it. So let's just say arbitrarily that it looks something like this. So this part right here, okay, this part right here is the slope. If you think about it, it's the slope of the secant line. Okay, so it's the slope of the secant line. In other words, it is if I were to connect these two, right, so the slope of the line that connects those 2 points is f of b minus f of a, whoops, sorry, I'm writing off the screen there, divided by b minus a. Okay. Now what this says is then there exists, okay, the key word is there exists a point somewhere in here where the instantaneous rate of change is equal to this slope. So if I take this ruler, okay, that's the slope of this line, and I should be able to slide it somewhere such that the instantaneous rate of change is equal to the slope of that secant line. So in this case, it's, let me put this ruler down for a minute here. So this is, right about here. So right about there, the slope of the tangent line here happens to be equal to this slope. Okay, so this is C. Okay, and so this is saying that there's got to be some point here where f prime of C is equal to this expression, f of b minus f of a over b minus a. Okay, so no matter how you draw this function, as long as it's differentiable, then the secant line between the two endpoints and that slope has to be equal to some instantaneous slope. Okay, so this is really saying there exists a point where the instantaneous rate of change so this is here, that's the instantaneous rate of change equals the average rate of change. Equals the average rate of change. So that's this part right here that I've circled in green. Okay, so that's essentially what the mean value theorem is saying. All right, and this is kind of an amazing thing. It says that if you find an average rate of change, then at some point in there, the instant rate of change has to equal the same value. Okay, and we'll see in a minute why, or in the next video, why this is useful in several cases. Okay, or in many cases. But before we go on to that, I just want to show you another form of this. So there's that form, and here's another form that may be useful in different circumstances. Okay, so another form of this is we can say that f of b is equal to f prime of c times b minus a plus f of a. Whoops, sorry, I'm writing this off the screen again. But this is really just solving for b. Okay, so this is really just another way of saying the same thing. If you take this equation up here and then we solve it for f of b, then we get this result. Okay, and we'll see in some examples why one version might be more helpful than another, or might be a little bit easier to recognize than the other. Okay. So that's it for this video about the mean value theorem for differentiation. So for derivatives, I didn't say that here, but this only applies for derivatives. There's another different mean value theorem that we'll learn later on, and another theorem we talked about today was Rolle's theorem. So make sure you understand both of these and what they're really saying and the conditions and the results of these. Make sure you watch the next video where we talk about the application of these theorems. Thank you for watching. Have a wonderful day.